All right. And last but not least, we're going to do a little anatomy here of the whole system, go into a little bit more details, because I know most of you are going to take anatomy here. So let's redraw our little heart. This is a good review. We've got our right atrium, right? We got our little right ventricle. And we're going to kind of cheat this. We're just going to draw this going up. And then we've got, we'll draw in our left atrium. And then we'll draw this. We'll just draw the start of that. And we'll draw the start of this. Okay, so we're going to name kind of the anatomy of the cardiovascular system here. You know, of the systemic and the pulmonary circuits, but we're going to go into a little bit more detail. All right, so we'll just start with this. So this part, okay, I might have to take this way down. Okay, so this part, obviously going to go up to the lungs, and I'm cheating on the way this goes. We're just going to have it go in one single direction here across the lungs, like so. This, and then we're going to have our lungs kind of do something like this. One lung, a two lung. Oh boy, no thank you. A two lung, and our pulmonary circuit going to go across those. And this bad boy here is going to take up a whole page, just so you know. All right, and now this is going to transition like so into oxygenated blood. And then this is, of course, going to reconnect here. And this anatomy is real wonky, but we're just doing this to kind of label it. Okay, so what is this? So our blood is coming up in this direction, right? So far. So what is this thing? This would be our pulmonary artery, right? If you remember that. Pulmonary artery. Okay. Pulmonary artery. There. These would be, or this would be our pulmonary vein. Okay. It's going to be low in oxygen here, high in oxygen here. Important to remember that. Okay. I guess that's it. That's the pulmonary circuit. Nice and easy. Let's go out this direction. So we're going to keep following along. And we're going to come out here. All right, we got this huge blood vessel right here. And this boy goes in two directions. I'm going to kind of draw it going way out here, so we can get away from that pulmonary circuit. It goes in two directions. It can either go up or it can go down. This thing is the aorta. This is the aorta. Aorta. All right, it's the biggest artery, comes out of right out of your heart. That's your aorta. All right, and then this thing is going to go up to your head and up to your arms. But if we're going up to your head, let's just say, we'll go right up to the brain. This is your carotid artery. Carotid artery. Okay. And this is, we'll draw a little brain here. Let's say, like so. And this comes up like this, splits off into little capillaries. So we go from arteries to arterioles to capillaries. It gets thinner and thinner and thinner, essentially. And then it's going to start to deoxygenate. as the oxygen gets used up by the tissue, right? Drawing this real sloppy. Please don't mind. Don't hate. Jesus. Whee. Let me put this pulmonary artery over here. And we'll connect that bad boy down. Okay, that looks like total garbage, but that's okay. All right, this coming back down, these would be like capillaries up here. This would be a capillary network. This would be jugular vein coming down through your neck. Jugular vein. Right up here. And then this would be your superior vena cava. All right, right there, going back into the heart. Okay, well, let's do this one now. And the blood is, of course, going to be going in this direction. Like this, up here, and it's oxygenated over here, and it's deoxygenated over here where I'm drawing. Okay, boom, that's one circuit done. All right, let's do this direction now. Let's go down. All right, we'll draw a couple little pieces of this just because I'll give you some more anatomy. Okay, so we're gonna have 3 little sections coming off of this bad boy. Boom. Oops, I wanted to draw this, keep continue. Keep continue. And one more little section. Okay. All right, this first little stop, we're going to go. This is our intestines. This will be our digestive system. Digestive system. And then we want to pick up nutrients, right? So we absorb those nutrients. We want to pick them up. So we do that. So we got a little capillary network out here. It's called your mesenteries that connect to all of this. Like so. And there's a special little structure here. Okay, this guy's very important. So this is all a vein. But then we got this other organ here. We'll draw it in green. I like to draw this guy in green. And I don't think we'll fill it in, actually. Not bad. Not bad at all. And then this actually reopens back up into kind of a, oops, what am I doing here? Blue. Back up into a capillary kind of network. And then we go back into okay. But you see this coming together. All right. Let's just finish all these off and then we'll label them. Down here, got a couple of things that look like little kidney beans. And then we've got, oops, capillary network where the blood vessels get real thin. And then we continue this on. Goes back into one big vein. Connect this down. It's coming together. And then we're almost complete here. This is just gonna connect around like this. I made that way too fat for my liking. Look at this, beautiful. Okay, beautiful. All right, cool. Now let's label all this. So this is going to be to your legs. For example, legs. These are obviously your kidneys. This guy here in green is your liver. That's your liver. All right, now let's label some of these. Here we've got, this would be our mesenteric artery. This would be our renal artery. Renal artery goes to your kidney. Anytime you see renal, that means kidney. And then this would be your iliac artery. Okay. That's pretty much the exact same on the opposite side, just different terms. Here we have our iliac vein. And then we have our renal vein. Here it's a little interesting though. Here we have our hepatic portal vein. And this is a really interesting thing. It's because this is all of our food, everything that we eat, we absorb the nutrients from it, and all the blood right from our digestive system first goes right into our liver so that we can detoxify any toxins that we consume. This would be then, or I'm sorry, this is the hepatic portal vein, and then this is the hepatic vein. These are both going towards the heart. Sorry, I got confused there for a second. That's just hepatic vein. This is called the portal vein because a lot of things come into it. So it's like a little portal to the liver. Yeah, and like just so we have this down, like anytime you see something like this, these would be like capillaries, which are just like a single capillaries. Capillaries? Oh, no, that's capillary. Capillaries. Capillaries. That's how you say it. If you're from South Africa, capillaries. This would be like a arterial. And this would be like a venule. It's just like a smaller vein or a smaller artery. Venule. And in between, even thinner, you have capillaries. Kind of where the two interchange, you can't really see the difference between them. All right, and then this thing here, last but not least, this would be our inferior vena cava. All right, now we got some pretty decent anatomy of the cardiovascular system. This thing up here would be our brain. Not bad at all. Looks a little trash here and there, but pretty solid actually. I think if there's any others that I want you to know, pulmonary artery, pulmonary vein. I think we're pretty good there actually. All right, so those are all fair game for the exam. Know those, know that basics there. Know the direction of flow. I didn't finish the flow, but the flow would go, obviously all this would flow like so. I don't want to make it too messy. I don't want to actually draw those in. It'll get a little too messy. We'll draw these in though. Okay, beautiful. Okay, just a few more things that I want to cover. Really just two more things. All right, so a key thing, especially down here in our legs, but really in all of our veins, we have little valves like this. Okay, so I'm going to redraw that kind of over here in this direction. Veins have valves. Arteries don't, but veins do. So let's just kind of redraw this in. And what does this look like? Oh, look, we got a little valve. So this can open as blood flows in this direction. But if blood tries to flow in this direction, it will close. Okay? And so let's say we're down in our calf and we got our calf muscle. So let's say we got a bunch of blood right there. Let's say we got a bunch of blood. And it's just kind of chilling there, but it's not moving. All right, and then we've got our calf muscle. We'll draw it in pink, not in red, because we drew the blood in red. We got our calf muscle, and it's, it's nice and relaxed around the side there. Okay? Let's contract this calf muscle now. And what it's going to do is it's going to pinch on that vein. All right, so this valve can open like so. And this blood, let's draw our calf in nice and contracted. Calf muscles contracted. I'll label this in a second. And then our blood, since it's getting squirted up, contracts up, squirts up, whoop, like so. Okay. And one more last thing. And now the calf muscle is going to be relaxed again. Like so. Pretty nifty. And this valve closes, right? Because of its shape. Calf muscles are relaxed. And the blood, it's not going to go any higher, but now it's just sitting right there. All right. So let's label this again, and then we'll walk through it. So this is relaxed calf, calf muscle, or your gastrocnemius, contracted calf muscle. The gastrocnemius, it's actually calf with an F. I was right. I was second guessing myself. Another name for this is gastrocnemius or gastronemus. You are going to have to know that, so I might as well spell it out here for you know. Gastrocnemius. Or gastrocnemius. You can say it either way. Contracted calf muscle and relaxed calf muscle. All right. This thing here is a closed valve, open valve, closed valve. And this is blood. So your calf muscles are often called your second heart because they help pump blood out of your legs and up into your body. Something like 2/3. So again, we relax calf, closed valve. We squeeze our calves, we pump blood up, and then if we relax our calves, that blood can't go back down because of this valve. Okay? We store something like 2/3 of our blood in our veins. And then like actually another leader is in our spleen. So then that means the rest of that is probably like a 2/3 of a third or something like that is in our arteries and actually being kind of pumped. It's like we're not continually pumping. Like some of the blood cells might sit in your veins for like a minute or something, depending on how it's going. It's pretty interesting. Okay, there's one last little thing I want to mention, and I'm actually going to go over here and grab this drawing just to speed things up. Just because I think this is cool and worth mentioning. Some of this stuff goes to things I learned in my PhD, some of it not. All right, but I'm going to grab this whole thing here. You don't have to redraw all of these details. Look at the kind of main idea here. Okay, so we got a white blood cell. And don't care about all that inner stuff. We got our endothelial cells. We got a bacteria. It's going to crawl. It wants to crawl through. Here's what I want. Here's what I want you to get. Okay, we got a bacteria. Cells of capillary or vascular tissue. Look at all this. All this is now coming together. Okay, what do I want you to get from this? I'm going to come up here actually again and do a little review. White blood cells, basophils. These guys go to sites of infection and release histamine. Signals to other white blood cells to come over. Also makes our veins leaky. Increases fluid flow to the site. Okay. Let's take him back. Let's take him down here. Look at this. I'm combining things from different lectures here to make a final little point about our cardiovascular system. I'm impressing myself. So we got this bacteria here. Let's say a basophil finds it first. All right, boom. Yeah, let me actually make another version of this. And this out here, we can now say that this is let's say this is a macrophage. I think I said it was a neutrophil originally, but let's say it's a macrophage because it's a big boy. We got a macrophage, which would be another word for that would be a monocyte. Monocyte. Okay. All right. And here we don't have the basophil. Here we don't have the basophil. The bacteria is there. The endothelial cells are tightly associated with one another. So the endothelial cells are what make up the walls of the artery or vein. Sorry, I should be clear on that. So the walls of the capillaries, those are made up of endothelial cells. All right? Endothelial cells are tightly associated with one another. There's no basophil here. All right? This is the main point here. We got a macrophage out there, bacteria here. How do we fix this? Well, we get a basophil over here. He releases a bunch of histamine. This basophil, or maybe she does, it's a lady. Bunch of histamine. Okay? Histamine is released by the basophil. And this causes the endothelial cells to kind of not hold on to each other so tight, become a little leaky. Released by the basophil, causing the endothelial cells to space out, bro, to loosen their grip on one another, allowing white blood cells to crawl through, which, if you remember, is called diapedesis, that process. Okay? It's pretty interesting. It's pretty interesting indeed. So that's how one of the ways histamine works. And this would also cause stuff like, so the cell can crawl through, cell can crawl through, cell can crawl through, and plasma leaks into the tissue. This would cause swelling to occur. But it would also add antibodies and things like that to the tissue. So it's not necessarily bad, but it can get out of control. Then we'd have our eosinophil come in and kind of tamp down this once everything's under control. This would allow this macrophage to come in, swallow up this bacteria, and slap it in its lysosome to digest it, for example. All right, one last little thing that I just think is cool. Whoa, 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 whoa. Whoa, 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 what just happened? All right, I'm just going to copy this. And we're going to put this down here. And I'm going to get rid of this. And we're going to make a top to it as well, just so it makes a little more sense. So we got our endothelial cells like this, and we got good blood flow. Good blood flow. Good blood flow. Very fast blood flow. And what does this create? It creates a strong, what's called shear force or pulling force. Strong shear or pulling force on the endothelial cells. All right. That's what that creates. And what this results in is the endothelial cells will be tightly associated with each other. All right. Now, let's change this. I'll do it down here. Let's reduce the blood flow. What happens? Let's reduce blood flow. Slow blood flow. And this will be weak shear or pulling force on the endothelial cells. And what this causes, you can probably guess, so we got a real weak blood flow. Probably guess what this causes to happen. These endothelial cells, again, they loosen their grip on each other. They loosen their grip on each other. Endothelial cells. I guarantee nobody else here at this college is teaching you this. It's pretty cool. Endothelial cells loosen their grip on each other. All right, so this is why, one of the reasons why, as we get further away from the heart and out into our limbs, we have fluid leaking out of our cardiovascular system. And this fluid, so now fluid will leak out again. I don't really have time to go into this. We talk about it a little bit in lab, but this then fluid is collected by our lymphatic system, which then eventually goes back into our cardiovascular system. So fluid leaks out, and is collected by our lymphatic system. Okay, so this is happening where our blood pressure is low. Where our blood pressure is low, such as in our limbs, at our extremities, this is occurring. And our lymphatic system is a part of our immune system. So there's a lot of white blood cells in your lymph nodes and our spleen and all that. So we're basically sampling our blood all the time with our major immune system organ as well. But these cells actually respond to the force. The endothelial cells actually respond to the force. And if you apply fast forces, they don't want to leak out that much blood because it'd be too much. But when it's the very low amount of pressure, we want to leak it out, sample it, soak it up into our immune system, big immune system, organ system, get rid of any infections that we find, start making antibodies for it. And so we can monitor our blood in a very rigorous kind of way in this sense. This is also why I don't want to go on too much longer. That's long enough. But I think that's pretty nifty that our cells are mechanically sensitive in our endothelium. Okay, so we have two ways that I'm talking about here to affect how tight the capillary cells are, our blood vessel cells are. We can adjust how tight or loose they are bound to each other, so how leaky the capillary is. By releasing histamine, histamine will loosen them up, causing them to be leaky, to allow us to fight infection. And the mechanical force from how much blood force is flowing across them. The less force, the more leaky. Pretty nifty. So for example, if we look at our aorta, this is right here, right outside the heart. This is going to be very tight, very tightly associated because it's going to be under a lot of shear force. Whereas down here, it's going to be pretty leaky. This is why if you get injured or something and you got or an infection or something, you want to keep it raised because you don't want to be overly leaky in those areas. All right. Look at this, guys. This was my entire Sunday. We did a lot. Thank you for going on this journey with me. Really, all of this, the main function of all of this is this, to supply oxygen and food to our mitochondria and to get rid of the waste product of carbon dioxide from mitochondria. It's really the main purpose of our cardiovascular system. Wow, I'm just looking back at this. Okay, and we started with a friggin' sponge. I forgot about that. Okay. All right, I'll see you in the discussion. I'm excited about this one. It's a cool one. Later.